When I first opened this unit up, I didn't really quite know what the use for it would be until I thought about it for a while, and then it all became perfectly clear, as you'll see once I get into it. It's actually a smart little product, and it actually does have a use, and it works as described. Let's check it out. I got another device from Xcentz. It says Tech That Gets You. This is they call this a power cube, and they wanted me to look at it and show you guys and tell you guys what I think of it. And well, let's take a look at this thing. I didn't know what to make of it when I first got it. It's a power tap, but unlike anything I've ever seen. It's a cube. You can plug this in to your regular outlet. And it's got 4 standard AC outlets on it, which is kind of a strange configuration. I can't think of how something like this would really be useful because, you know, I mean, sure, you could have 3 things plugged into it, but the 4th one would be on the bottom. That's kind of a silly design. It also has 3 USB ports on it. So you can plug in 4 AC devices, such as other adapters. And it has 3 USB. We're going to put this thing under a load and test it and see how it works, and maybe we'll even crack this thing open. Looks like it's 2.4 amps total, shared between the 3 outlets. So it's not a fast charger. Let's look at the specs for this unit. Here's the specifications. Of course, you have your outlets, you've got your USB ports. It's got an overload switch, so obviously if you overload it, it's going to pop this little button out, and I'm sure that probably applies to the AC as well as the 5 volts. It's 125 volts, 60 hertz, 15 amps, or 1875 watts total for the AC outlets, and your USB ports is 5 volts, 2.4 amps total. There's 4 outlets and 3 ports. And there's not much else to it. I love what they have to say here. Safety information. Here are some helpful tips on how to safely use your device. It says, please read them. Ignoring these instructions could result in damage to your device. It says, do not use a device in excess of its output rating. Overload outputs above the rating may result in damage to the device. Do not put your fingers or hands into the device, so don't stick anything into there. Do not open or crush or bend. Do not use harsh chemicals. Do not expose the device to rain or snow. Do not spill coffee on the device. Drop it in beer or get it wet with liquid of any kind. Why did they just limit it to coffee and beer? So do not use a device that is damaged. A damaged device may exhibit unpredictable behavior resulting in fire or risk of injury. Do not disassemble the unit. Take it to a qualified service person. Do not expose the device to fire or excessive temperature. And have the service performed by a qualified repair person. I doubt that anybody's going to be repairing something like this. And it says avoid dropping the unit and use it indoors only. Now, it has an 18-month limited warranty, lifetime technical support, and 30-day refund. And they get their phone number here for contacting them. And I thought this would be one for testing. We'll test this and see how well it works and what type of a load we can put on it. And are we able to open this thing up and see what's inside it. Now, when I first saw this unit, I couldn't figure out what the practical use would be. And then it clicked. If you've got a desk that's got one of the pre-cut holes, like for passing cables, like for your keyboard and so forth over it, you drop the unit through that cable access hole, you plug it into the wall, and now you've got a 4-port AC cube on your desk with 3 USB charge ports. I thought that's actually a great idea. And that's exactly what I've done. I've got it sitting on my desk, and now I've got 4 AC outlets available on my desk and 3 charge ports for USB. Cool design. So to test this for the USB current capability, I've got my resistor dropper array here, which will pull this thing down to a full load of a couple of amps. Got my little meter here, and this will tell us the voltage, 5.2 volts, 0 amps. And when I plug this thing in, this will start to draw current, and I'm drawing 2.5 amps on that, which is pretty much what this thing is rated at, 2.4. So we're going to draw full power, but as you can see, at 2.5 amps into my resistor network, which is going to get hot enough to melt the solder that is soldering the resistors together. As you can see, I am able to draw 2.5 amps, so I'm drawing full power from this unit. It's rated at 2.4. If I were to put more of a load on here, I'm going to cause it to go into a shutdown mode because it is rated at 2.4, and I'm able to draw 2.55 so far. If we look at some of the other settings here, so 33 milliamp hours, 181 milliwatt hours is what's being drawn, and I can feel the heat coming off of these already. And here's our graph showing that the voltage is stable. To give you an idea how hot these resistors are getting, it should be almost hot enough, if it isn't already, to melt this solder, because these get very, very hot. And there it is. It's melting the solder. A lot of heat being produced in these resistors and into the wires. The unit's been running now for about 20 minutes, and no worse for wear. Still drawing the full current. I'm going to unplug this now, and we're going to see whether we can open this unit up and see what's inside it. So first, I'm going to unplug it, because this is a mains operated device. I'm just going to move these resistors out of the way so that they can, that bench is pretty warm where they were sitting, so that they can cool down, and we'll figure out how to get into this thing. At first I thought this thing might be glued together, but then I realized there's a sticker on the back here, and if I pry off the sticker, it's got conventional screws holding it together. So, oh, they're not conventional screws. They're 3-sided security screws. Well, I just so happen that I have a screwdriver that will fit those. Four screws, and we're in like Flynn. Top comes off. Ah, cool. Okay, so here's what we've got inside this unit here. Conventional is just conventional copper strips that form the plug, and they're all snap fit in. But what we're really interested in is we're interested in the low voltage side. So as you can see, they've got a barrier here to shield the low voltage components from making contact with any of the higher voltage components in here, namely the ground wire, or these wires that go to the circuit breaker. Here's our USB plugs and our inverter. It uses a proper transformer. It's a switching power supply, and the capacitors are rated at 400 volts, which tells me this is a universal type power supply. It can run on 220 as well, but obviously it's the same board they would use for a 240 version of this, but this is obviously 120 because it's got the 120 cord set on it and 120 plugs. But here's your DC to DC converter. Ooh, didn't like that. Looks like one of the wires here is kind of crunched and caught up against this, up against the cabinet here. Not damaged, but it was pinched, that's for sure. These are your DC wires from the output. And it's just a standard inverter type DC to DC converter. And here's the 3 USB plugs with current regulation ICs. Relatively straightforward, nothing fancy here, but at least they've used a proper transformer and not just a capacitor dropper as some companies would use. So I'm just going to stick this back down here, and then we'll put this unit back together. I'll stick it back down with some VHB tape. And then this was in just like this. See, I know which way it came in because I was trying to pry it apart first before I realized that it actually had screws in it. Most of these things don't. Most of these things, they are put together with, they glue them together. But this one here was the exception because this one here came apart quite easily once I got that sticker off the back. You know where I think this might be useful? In one scenario that I can see something like this actually being quite useful. I was thinking about it. I thought, where could you use something like this around the house? Because of its odd shape. And then it came to me. You got a desk that's got the hole to pass your monitor cables and stuff through, and your keyboard and stuff. You know, they got the round connector. You drop the cord down through the connector, kind of represented by this roll of tape. And the cord drops down through your desk and plugs into an outlet, and you've got your cube with your 3 USB ports and 4 power connectors for plugging things in on your desk. And that actually might come in useful. And I think I might just do that because my desk just so happens to have those knockouts that you can feed cables through. You can feed this through those, stick this up at the top, and then I'll have power and charge ports on my desk. I think that just might be what I use this for. I had thought about it for a bit. This is kind of an odd design. It didn't make a lot of sense, but if you're feeding it up from below a desk and the cable can drop straight down, so it's not sitting on its side, it's sitting like this, then it becomes a useful device. And that just dawned on me that that's probably what it's designed for. And that's what I'm going to do with it. Anyway, link to this is in the description. As I say, it looks like it's not a bad design. I am getting full current out of it. Yes, I know, I always end up wrecking the ones that I've got here, so I can't sell them, right? Because this was sent to me promo, so it's not like it's something I can give away or sell. Once it's been in my hands, it's going to have some damage to it, but the whole point in this was to take it apart and see how well it's built. I don't see anything wrong with this. Everything looks to be okay on this one. At least it's not using one of those capacitor droppers like some of the cheap ones use. It's got a proper power supply in it. Thanks for watching. Catch you in the next one.